You think we just need better technology to see inside black holes, better telescopes, better detectors, better instruments. Eventually, we'll peer through the event horizon, image what's inside, see the singularity, understand black hole interiors directly. It's just a matter of time and engineering, like everything else in astronomy. We couldn't see distant galaxies until we built Hubble, couldn't detect gravitational waves until we built LEGO, couldn't image black hole shadows until we built the Event Horizon Telescope. So eventually we'll build something that sees inside black holes, solves the mystery, shows us what's really there. That's the natural assumption, the obvious extrapolation. But it's completely wrong. We will never see inside a black hole. Not because our technology isn't good enough, not because we haven't built the right instruments yet, because it's physically impossible, fundamentally impossible. The laws of nature forbid it absolutely. No technology can overcome this, no instrument can bypass it, no clever technique can work around it. The event horizon is not just a barrier we haven't crossed, it's an absolute boundary, a causal boundary. Information cannot escape from inside, cannot reach the outside, ever, under any circumstances. This is not engineering limitation, it's fundamental physics, and understanding why tells us deep truths about causality, information, quantum mechanics, and the nature of physical law itself. Let me start with what the event horizon actually is, because most people fundamentally misunderstand it. They think it's a surface, a membrane, a physical boundary you could touch if you got close enough, some kind of barrier surrounding the black hole, like the surface of a planet or star. But the event horizon is not a physical surface, not made of anything, not a place where anything dramatic happens locally. If you fall through an event horizon, if you cross it, you feel nothing, detect nothing unusual, experience nothing special. Space-time is perfectly smooth there, no discontinuity, no boundary, no warning sign. For a supermassive black hole, millions or billions of solar masses, the tidal forces at the horizon are negligible, barely noticeable. You could cross the horizon and not know it, not realize you've passed the point of no return, not until much later when you try to escape and discover you can't. But at the moment of crossing itself, nothing happens. The horizon is not locally special, not a physical thing you can point to and say, there it is. It's a global feature of space-time geometry, defined by what happens in the complete future, in the infinite future, not by what happens locally at any particular moment. Here's what the horizon actually is. It's the boundary of the region from which light can escape to infinity, the last surface from which photons can still reach distant observers, cross inward past that surface, and even light cannot escape, not because something grabs it, not because there's a barrier, because the geometry of space-time inside the horizon is such that all future directed paths lead inward, toward the singularity at the center. There is no outward direction, not that outward is blocked. That outward doesn't exist as a future direction. Inside the horizon, the radial coordinate becomes time-like. Time and space swap roles. The singularity is not a place in space. It's a moment in time, your inevitable future, like tomorrow. You cannot avoid the singularity any more than you can avoid tomorrow. You're not falling through space toward it. You're falling through time toward it, moving inexorably toward your future, toward the moment when space-time curvature becomes infinite, when tidal forces become unbounded, when you're destroyed. That's the singularity, and it's in your future, causally ahead of you. You cannot send information backward in time, cannot send signals to your past, so you cannot send information from inside the horizon to outside observers. They're in your past, causally disconnected, beyond reach, forever. This is fundamental, built into the causal structure of space-time, into the light cone structure, into what can affect what. The event horizon separates space-time into two causally disconnected regions, inside and outside. Information from inside cannot reach outside, not through any mechanism, not with any technology, not even in principle. It's not about signal strength, not about detection sensitivity, not about having powerful enough transmitters or receivers. It's about causal structure, about what can influence what in space-time. And the answer is nothing inside can influence anything outside, ever. The causal future of events inside the horizon is entirely inside the horizon, stays inside, never reaches outside. The horizon is a one-way causal boundary. Information flows in, never out. This is absolute, unbreakable, fundamental to general relativity, to the structure of curved space-time. No technology can change this. No discovery can bypass it. The laws of physics forbid it, period. But you might object. What about Hawking radiation? Black holes aren't completely black. They emit radiation, thermal radiation. Hawking proved this in 1974. Black holes evaporate, slowly lose mass, eventually disappear completely. So information does escape, does get out through Hawking radiation. Doesn't this prove we can see inside black holes? Just detect the Hawking radiation, decode the information, reconstruct what fell in, see the interior. No, this is a fundamental misunderstanding of Hawking radiation. Hawking radiation does not come from inside the black hole, not from beyond the event horizon. It's created at the horizon by quantum effects in curved space-time near the horizon. Virtual particle pairs appear near the horizon. One particle falls in, one escapes. The escaping particle is Hawking radiation, but it never was inside the horizon. It was created just outside by quantum fluctuations of fields. The black hole loses mass, shrinks. But nothing escapes from inside. The information in Hawking radiation, and there is information there, subtle correlations encoding what fell in, comes from the horizon itself, from the quantum state of fields at the horizon, not from the interior. The interior remains absolutely causally disconnected, absolutely inaccessible forever. And there's something deeper here, something about the nature of the interior itself. In classical general relativity, the interior is a region of space-time, a volume, existing independently, with its own geometry, its own physics. Information falls in, exists inside, sits there, inaccessible but real. But quantum mechanics suggests this picture is wrong. The holographic principle says the interior is not an independent region, not additional physical degrees of freedom. It's a holographic projection, a derived description, a way of describing information that's actually encoded on the horizon, on the two-dimensional surface of the event horizon, not in the three-dimensional interior volume. The interior is redundant, emergent, not fundamentally real as separate from the boundary. This is shocking, revolutionary, but it's what quantum gravity seems to require, what black hole entropy suggests, what the information paradox resolution demands. Here's why. Black holes have entropy. Bekenstein and Hawking calculated it in the 1970s. The entropy is proportional to the horizon area, not the volume. Area in Planck units. Each Planck area contributes roughly 1 bit. The horizon is covered with Planck-sized pixels. Each pixel is an information bit. That's the entropy. That's the information content of the black hole. But entropy counts degrees of freedom, counts independent quantum states. If entropy scales with area, not volume, then the degrees of freedom live on the area, on the horizon surface, not in the volume, not in the interior. The interior has no independent degrees of freedom, no additional information beyond what's on the horizon. It's holographic, derived, emergent from the boundary data, not fundamentally separate. This is the holographic principle, proposed by 't Hooft and Susskind in the 1990s. confirmed by ADS CFT correspondence. Maldacina's discovery. A gravitational theory in a volume is exactly equivalent to a quantum field theory on the boundary. The interior emerges from the boundary theory. Space-time emerges from quantum entanglement on the boundary. Black hole interiors emerge from thermal states in the boundary theory, all provable, calculable. In ADS CFT, this is exact, not approximate, not analogical, exact mathematical equivalence. The interior is a hologram, a useful description for certain observers, but not fundamentally real as additional physics beyond the boundary, just a different way of describing the same information that lives on the horizon. So, what does this mean for seeing inside black holes? If the interior is holographic, if it's not fundamentally separate from the horizon, then there's nothing additional to see. The information is all on the horizon, encoded there, scrambled, maximally entangled, impossibly complex, but there, not hidden inside. Inside is just another description of the same information, like looking at a hologram from different angles. Different perspectives give different images, but it's the same hologram, same information. For an observer falling into the black hole, the interior description is useful, natural. They experience falling through space, approaching the singularity. That's their description, their perspective. But for an outside observer, the horizon description is fundamental. They never see you cross, see you asymptotically frozen at the horizon, redshifted, fading, but never crossing. Both descriptions are valid. Neither is wrong. They're complementary. Different slicings of the same physics. Black hole complementarity. Susskind's proposal. The information is both inside and outside. Both descriptions coexist. For different observers, different perspectives, but fundamentally there's only one set of degrees of freedom on the horizon. The interior is derived, emergent, holographic. This resolves the information paradox. Hawking's original argument said information is lost, falls into black holes, gets destroyed at the singularity, disappears when the black hole evaporates. But quantum mechanics forbids information loss. Unitary evolution. Information is conserved. Paradox. Resolution. Information never enters the interior in the fundamental description, stays on the horizon, gets scrambled, gets encoded in subtle correlations, eventually gets released in Hawking radiation, slowly, over the evaporation time, scrambled beyond recognition, computationally inaccessible, but present, not lost, not destroyed. The interior is just a way of describing the same information from a falling observer's perspective, not a separate physical region where information hides. No information loss, no paradox. Information preserved on the horizon, released in radiation. Black hole evaporates completely. Information recovered, in principle, even if practically impossible to extract. But this creates another paradox. The firewall paradox. If information is encoded on the horizon, if outgoing Hawking radiation is maximally entangled with earlier radiation already escaped, then late radiation cannot be entangled with infalling matter, cannot be entangled with things falling into the black hole. But smooth spacetime at the horizon requires entanglement between inside and outside, between Hawking radiation and infalling matter. That's what equivalence principle demands, what general relativity requires. But quantum mechanics forbids a system being maximally entangled with two different systems independently. Monogamy of entanglement. Something must break. Either the horizon is smooth and information is lost, or the horizon has a firewall, a violent surface incinerating anything that crosses, and information is preserved, or something else we don't understand. This paradox remains unresolved, actively debated, cutting edge of theoretical physics. Quantum gravity, black hole information, we don't have the final answer yet, but whatever the resolution, whether there are firewalls or not, Whether equivalence principle holds exactly or breaks down subtly, one thing is certain: we cannot see inside black holes, cannot access the interior region, cannot retrieve information from beyond the horizon. The causal structure prevents it absolutely, and the holographic principle suggests there's nothing additional inside anyway. Just a different description of horizon information. So seeing inside is meaningless, like asking to see the interior of a hologram from outside. The hologram is a surface. The interior image is projection, illusion of depth, not real separate space. Similarly, black hole interior is projection, holographic image, not real separate region, just derived description, useful for infalling observers, but not accessible to outside observers, not containing additional information, not separate physics. And there are practical barriers too. Even setting aside causal structure and holography, even imagining somehow you could receive signals from inside, you couldn't, because of redshift, infinite redshift. As light climbs out of the gravitational potential well, it loses energy, gets redshifted, wavelength increases, frequency decreases, energy decreases. Light from near the horizon is enormously redshifted. From exactly at the horizon, it's infinitely redshifted, zero energy, infinite wavelength, undetectable. Even if a signal could escape, which it cannot, it would be redshifted to nothing. No energy remaining, no information content, undetectable by any receiver. The infinite redshift makes the horizon perfectly opaque, perfectly black, not because it absorbs light, because it redshifts escaping light to zero energy, makes it vanish, become undetectable. This is why black holes are black, why the horizon appears black to distant observers, not absorption, infinite redshift. And time dilation. Clocks near the horizon run slower, infinitely slower at the horizon exactly. From a distant observer's perspective, everything near the horizon is frozen in time, moving infinitely slowly. An observer falling through the horizon appears to slow down, asymptotically approach, never quite reach, freeze there forever, redshifted, dimmed, fading, but never crossing. This is the outside observer's description, valid, accurate, consistent with general relativity. The infalling observer experiences differently, falls through in finite proper time, but the outside observer never sees it, never sees the crossing. The time dilation makes events at the horizon take infinite time to occur, to be observed. So even if information could escape, which it cannot, it would take infinite time to reach you. Never arrive in finite time. Make seeing inside impossible even without causal barriers. So multiple independent reasons converge. Causal structure prevents information escape. Event horizon is one-way boundary. Holographic principle says interior is not separate region. Infinite redshift makes horizon opaque. Infinite time dilation freezes events there. All conspire, all agree, all say the same thing. We cannot see inside black holes, not with better telescopes, not with better detectors, not with any technology, not even in principle. The laws of physics forbid it absolutely, permanently, forever. What about quantum gravity? Won't deeper understanding change this? Show us how to access interiors? No. Quantum gravity will clarify the picture, resolve paradoxes, tell us what really happens at horizons and singularities, but it won't change causal structure, won't allow information to flow backward through time, won't violate causality. Whatever quantum gravity says, it will preserve causality, preserve the one-way nature of horizons, probably make the holographic picture more precise. Show us how interiors emerge from horizons, how space-time comes from entanglement, but not allow seeing inside, not permit accessing information from beyond horizons. That's forbidden by causality, by unitarity, by consistency. Quantum gravity will deepen understanding, but not enable the impossible. Some hope for wormholes. Maybe wormholes connect to black hole interiors, allow access from outside, traversable wormholes, Einstein-Rosen bridges. But wormholes have the same problems as warp drives, require exotic matter, negative energy, violate quantum inequalities, create time travel paradoxes, are probably impossible, and even if they existed, they wouldn't help. A wormhole to a black hole interior would have a horizon, would be causally disconnected, would exhibit infinite redshift, same problems, same barriers, no access, no seeing inside, just different geometry, same impossibility. Others think singularities are doorways, portals to other universes. Pass through the singularity and emerge somewhere else, white holes, other regions of space-time. But singularities are not places. They're moments in time, your future. You don't pass through them. You end at them. Space-time curvature becomes infinite. Tidal forces become unbounded. You're destroyed, spaghettified, crushed to zero volume. There's no passing through, no emerging elsewhere, just destruction. End of your world line. Classical general relativity says so. Quantum gravity might modify this, might resolve the singularity, replace it with something smooth, a bounce, a transition, but even then you cannot send information back, cannot communicate with the outside. The causal structure prevents it. The singularity, or whatever replaces it, is in your future, causally ahead. You cannot affect your past, cannot reach outside observers. They're in your past, done, finished, beyond influence. So we will never see inside black holes. This is not pessimism, not defeatism, not lack of imagination. It's physics, fundamental physics, causal structure, information theory, quantum mechanics, general relativity, all converging, all agreeing, all forbidding access to black hole interiors. We can see the horizon. We've imaged it. Event Horizon Telescope photographed M87's black hole shadow in 2019, Sagittarius AA in 2022, beautiful images confirming general relativity, showing the photon sphere, the shadow, the horizon, but not the interior, never the interior. We can detect Hawking radiation in principle, might someday, from small black holes, primordial black holes if they exist, evaporating, emitting detectable radiation. We could study that radiation, learn about the black hole, about what fell in, from subtle correlations in the radiation, but that's studying the horizon, not the interior. The radiation comes from the horizon, encodes horizon information, not interior information, because there is no separate interior information. It's all on the horizon, holographically encoded. We can send probes into black holes, spacecraft, instruments falling in, taking measurements, recording data, for science, for knowledge. But those measurements stay inside, cannot be transmitted out. The probe crosses the horizon, continues measuring, falls toward the singularity, experiences the interior, gets destroyed, but its data dies with it, never reaches us, cannot reach us. Causal structure forbids it. The probe's information gets encoded on the horizon, gets scrambled, eventually gets released in Hawking radiation billions or trillions of years later. Unrecognizable, impossible to decode, computationally inaccessible, practically lost even if theoretically preserved. So sending probes doesn't help, doesn't let us see inside, just sacrifices instruments for nothing. For data we can never retrieve. This is the reality, the hard truth, the fundamental limitation, not of our technology, not of our current understanding, but of physics itself, of the structure of space-time, of causality, of information theory. We will never see inside black holes, not because we're not clever enough, not because we haven't tried hard enough, because nature forbids it. The universe has drawn a line, a boundary, the event horizon, beyond which we cannot see, cannot access, cannot know, not through observation, not directly. We can infer, can calculate, can theorize, can use general relativity to predict what's inside, what the geometry should be, what happens to infalling matter. We can use quantum mechanics to understand information content, to know it's preserved, to know it's on the horizon, but we cannot observe directly, cannot see, cannot measure, cannot verify experimentally. The interior is forever beyond our direct observational reach. Why will we never see inside a black hole? Because the event horizon is a causal boundary, because information cannot escape from inside, because infinite redshift makes the horizon opaque, because infinite time dilation freezes events there, because holography says the interior is not a separate region, because causality forbids backward information flow, because quantum mechanics preserves unitarity on the horizon, not in the interior, because general relativity's causal structure is absolute, because the laws of physics converge to forbid it, all of them, independently, multiply, definitively. We will never see inside black holes. That's not speculation, not opinion, not pessimistic prediction. It's physics, fundamental, established, true. And accepting this, understanding this, recognizing the absolute nature of this limitation is part of understanding what black holes are, what horizons mean, what causality requires, what the universe permits, and what it absolutely forbids forever.